Good afternoon and morning, depending on when you're doing these notes. I hope you're having a great day. Today we're going to talk about number properties and how they apply to algebra. When we're done, we should know how knowing number properties can help us solve algebraic expressions. Once again, your topic is number properties in algebra, and your essential question is how can knowing number properties help us solve algebraic expressions? And that word right there is expressions. It is kind of funny. I smushed it in there really tight, but it is expressions. That's that word. All right, pause the video if you need to so that you can write that down. Otherwise, we're going to get right into there, and I'm going to give you guys some definitions of several different properties that really help us when we're doing algebra. Let me see if it helps if I turn the light on. Okay, so the first property we're going to talk about is the commutative property. Commutative property. Now, the commutative property, think about commuting. When you commute, you go from one place to the next place. You're not a different person. So if I commute to San Diego for work, when I leave Hemet, I'm Miss Engel. When I get to San Diego for work, I'm still Miss Engel. I'm the same person. I've just commuted to a different place. That's very similar to the commutative property. It applies to addition and multiplication. So if you were to have A plus B, that would be equivalent to B plus A. It doesn't matter where the A is or where the B is. As long as you're adding them, they can go and they can flip-flop. This also is true with multiplication. So you could have A times B is the same as B times A. It doesn't matter. This also could look like if you had 2 times 3 equals 3 times 2. They both have the same value. So that is our first property, the commutative property. The next property we're going to look at is the associative property. So with the associate property, our numbers are associating with different numbers or different values, and they stay the same. So this also applies only with addition and multiplication. So if you were to have, for example, A plus parentheses B plus C, right now B and C are associating with each other, but you could move that and you could have A and B associate with each other and it would still have the same value. So it doesn't matter if the association is happening between this addition problem or this addition problem. As long as it's all addition, it's going to have the same value. This also applies with multiplication. So I could have a multiplication problem that looks exactly the same. A times B is the same as A times the quantity of B times C. In associate property, it doesn't matter which one they're associating with, they still have the same value. So that's our second property. Remember, at any point, you can pause the video if you need to, so you can slow it down a little bit if you need to, okay? The next property we're going to talk about is the excuse that lack of being able to speak, the multiplicative property of 0. Multiplicative property, I'm going to abbreviate that, of 0. Okay? This one is one you've been doing since you've been doing multiplication, and basically it means that anytime you multiply any number by 0, it's going to equal 0. So any number times 0 equals 0. You know that. It just has a funny name, the multiplicative property of 0. We also have the distributive property. And the distributive property basically means it doesn't matter whether the factor is distributed throughout the problem or at the beginning of the parentheses, it's going to have the same value. And let's look at what that means, okay? So if I were to have A on the outside and B plus C on the inside, okay? So this is telling me that this A is going to distribute into these things within the parentheses. So it's going to look like this. Instead of A times B plus C, you would have A times B plus A times C. Sometimes this is called the rainbow property because you're doing this and this and this and this, and you kind of get a rainbow effect. Let's try another one. So if it also would apply with if you had some subtraction in there. So instead of A close that parentheses, Miss Engel. Okay, so instead of an addition problem, you can have a subtraction problem, and it's the same thing, A times B minus A times C. You just distribute that A within the property. So it kind of looks like this. If I had 3 and then I had, let's say, 6 plus 2 equals, this would be the same as going 3 times 6 plus 3 times 2. It has the same value, okay? And then you could solve it out and you could say, okay, well, 3 times 6 is 18, plus 3 times 6 is 6, or 3 times 2 is 6. Then you would add that out and you would get 24. So basically just take whatever's on the outside of the parentheses and distribute it in and keep the same operation. The key, guys, is you got to keep that same operation. So notice that there's addition out here and there's still addition out here. If this was subtraction, this would stay subtraction. With the distributive property, you got to keep that same operation. The distributive property. All right. I should put a title in here. The number properties. All right, another number property is the additive property, or I'm sorry, additive identity property. And this is another one you've been doing for a long time, and it's going to seem like, oh, that's common sense. But it basically means that any number plus 0 equals that number. So the multiplicative property of 0 is any number times 0 equals 0, but the additive identity property is any number plus 0 equals itself, which seems common sense, but there is a property associated with that. We also have the additive inverse property. So the additive inverse property is any number plus the negative of that same number. So a positive number, when you add the same number as a negative, it's going to equal 0. And this one makes sense if you think of a number line. If I were to go if I were to go positive 5 on a number line, and then I were to go back negative 5 spots on that number line, I'm going to be at 0. Basically, I'm just going to take away whatever progress I've made. But that's the additive inverse. And remember, inverse in math means opposite. So we have another property, the multiplicative identity property. And so just like this one, when you add 0, it stays the same. When you multiply by 1, it stays the same. So if you add a 0 or you multiply by 1, your number is not going to change. It's going to stay the same. And then the final property I want to talk to you about is the multiplicative inverse property. Let me move this up a little bit. And that basically means it's kind of like our reciprocals, how we talked about. If you take A over B and you multiply it times B over A, it's going to equal 1, because this times this is going to equal a number that's going to be equivalent to this times this. And then when you have a number that's the same on the top and the bottom as a fraction, it is a value of 1. So there are some very important properties. We can just draw little arrows. We have all these fun properties that we learn in math and we use very frequently. And they're going to help us because when we come into algebra and we get to a problem, sometimes we don't know what to do. And these properties will help us know what do we do. There's also another thing I want to talk to you about with algebra, and I realized yesterday that we really needed some more time on this, is words for algebraic expressions. And this is going to be another tool you're going to use when you're doing algebra to help you to know what is the problem asking you to do, okay? And so what this means is basically when you see certain words or phrases, it's going to tell you what type of math you're going to do, okay? So the first one is for addition. Excuse me. We know a problem is asking us to do addition if we see the words plus, added by, sum, or more. We know we have subtraction when we have the words minus, subtracted by, difference, or less. And sometimes it's less than. Okay, so let's give you some examples of these two. If I were to have a problem where I wrote out the sum of 6 and 2, well, I'm asking you to do an addition problem to add 6 and 2. If I were to give you a problem that said, what is the difference of 7 and 3? Well, I'm looking at 7 minus 3. I'm going to be getting the answer 4. So those words are very important to help us know what we are supposed to be doing according to our math problems. All right, let's keep going now to another one. What about multiplication? Now, we know we have multiplication if we have the words times, product. Here's some ones you might have forgotten, but also per. So like miles per gallon, you're multiplying the amount of miles per the amount of gallons that you have. We could have groups of. And here's another fun one, twice. And that means we're doing 2 times whatever. Now, I'm running out of some space, so I am going to go to the page, the prior page, so that I can have a little bit more space. I'm turning and going to the top. So what did we miss? Okay, well, we have got more than you think, actually. So one that you probably realize we're missing is division. So we know it's a division problem when we have the words quotient, divided into, or split up. So 16 brownies split up into how many groups for 6 kids? Kind of thing. Excuse that sound. Okay. All right. And then we also have a few more. We have exponents. For exponents, we're looking at to the power of. We could have squared. We could have cubed. Those all would be examples of words that we find for an exponent. And then we also have parentheses. So we know we have parentheses if we have words like the sum of. That tells me I'm going to do that first. The sum of 6 plus 2 multiplied by 3. So I'm going to do 6 and 2 and then multiply by 3. We could also do the product of. We could have the difference of. And here's another really good one, the quantity. Whenever you see the quantity, that's a big sign. Do that first. Like, that's a big one. When you hear, like, the quantity of 6 and 2 plus 12, you're going to do 6 and 2 first. Okay, so let's do an example before we finish up here. So here's an example. If I had the quantity of H and 3 times 7. So normally in a problem, I would be doing my, the multiplication problem first. But because I see this word, the quantity of, that tells me I'm going to be doing that first. So this problem is going to look like the quantity of, I'm adding them. So I'm going to say H plus 3, and I'm going to put in parentheses to signify that that's going to happen first. Then once I'm done with that, I'm going to multiply it times 7. Now remember, you can just put the number next to times. You could put it just next to the parentheses, or you could put the symbol there if you want, okay? And that's how you would do this problem. And then when we actually go to solve, we're going to have a distributive property that we'll be using. And we'll actually do 3 times 3, or 3 times 7, and 7 times h. So kind of using both. So this, if we use the distributive property, we would be looking at 7 times h plus 7 times 3. So we distribute that into it. So that's using both. So that would be an example of this distributive property. Kind of cool. Well, that is some of the basics of algebra that are really important to know. Please go back and pause the notes or slow down the notes or review the notes again if you have any questions. And if you have any other questions, also make sure you come to class and you ask me. I'm happy to help anytime. You guys have a wonderful day and take care. I will see you soon. Bye.